Hello everyone, and welcome back to our Network Plus course. In this lesson, we'll dive into two main areas: dynamic addressing using DHCP and name resolution with DNS. First, let's talk about dynamic addressing and the role of DHCP, or Dynamic Host Configuration Protocol. DHCP is a network management protocol that automates the process of configuring devices on IP networks. It assigns IP addresses and other critical network configuration parameters dynamically, allowing devices to communicate on the network without manual intervention. One key feature of DHCP is reservations. DHCP reservations ensure that specific devices always receive the same IP address whenever they connect to the network. This is particularly useful for devices that require a consistent IP address, such as servers, printers, or network-attached storage devices. Another important concept is the scope. A DHCP scope defines the range of IP addresses that the DHCP server can assign to clients. It includes not just the pool of available IP addresses, but also the subnet mask, default gateway, and DNS server information. Moving on to name resolution, which is primarily handled by DNS, or Domain Name System. DNS is the cornerstone of Internet functionality, translating human-readable domain names, like www.example.com, into machine-readable IP addresses, enabling devices to locate and communicate with each other over the network. Understanding different DNS record types is essential for effective name resolution and network management. Address record maps a domain name to an IPv4 address, allowing devices to locate servers on the network. For a record, similar to A records, but maps domain names to IPv6 addresses, supporting the newer IP addressing scheme. Canonical name creates an alias for a domain name, allowing multiple domain names to point to the same IP address. This is useful for managing multiple services under a single domain. Mail exchange directs email traffic to the appropriate mail servers for a domain, ensuring that emails are delivered correctly. Text stores arbitrary text information, often used for verification purposes and implementing security measures like SPF, Sender Policy Framework. Name server specifies the authoritative DNS servers for a domain, directing queries to the correct servers. Pointer provides reverse DNS lookups, translating IP addresses back into domain names. This is useful for network troubleshooting and security verification. In summary, implementing IPv4 and IPv6 network services involves a thorough understanding of dynamic addressing through DHCP and effective name resolution using DNS. Thank you for joining us today, and see you next time.